The night sky is adorned with countless stars, each a distant sun radiating light and heat. Stars are fundamental building blocks of galaxies, and their life cycles play a crucial role in shaping the universe as we know it. From the elements forged in their cores to the planets that may orbit them, stars hold the keys to understanding our place in the cosmos. Stars provide light and heat, essential for life on planets like Earth. They are also cosmic factories producing elements like carbon, oxygen and iron, which are the building blocks of everything around us. Stars begin their lives in vast, cold clouds of gas and dust known as nebulas. These cosmic clouds are scattered throughout galaxies and serve as the stellar nurseries where stars are born. Nebulas are mostly composed of hydrogen and helium, the two most abundant elements in the universe. These clouds can be immense, spanning hundreds of light years across. Within these nebulas, the seeds of stars are sown through a delicate interplay of gravity, turbulence, and time. Gravity is the driving force behind star formation. It acts like an invisible hand, pulling together the gas and dust within a nebula. As gravity draws matter inward, the cloud begins to collapse under its own weight. This collapse causes the density of the nebula to increase, particularly in the center. As the cloud collapses, it also starts to spin faster, like a figure skater pulling their arms in during a spin. As the cloud continues to collapse, the central region becomes denser and hotter, forming a protostar. A protostar is not yet a true star, as it is not yet hot enough to sustain nuclear fusion in its core. Protostars are surrounded by disks of gas and dust, which may eventually coalesce to form planets. These protostars continue to accrete material from their surroundings, growing in mass and temperature. Section 5. Igniting the furnace, nuclear fusion and the birth of a star. Eventually, the core of the protostar becomes so hot and dense that nuclear fusion begins. This process involves hydrogen atoms fusing together to form helium, releasing an enormous amount of energy in the process. This energy release is what powers a star and causes it to shine. The outward pressure from nuclear fusion balances the inward pull of gravity, creating a stable star. Section 6. The main sequence, stellar adulthood. Once a star achieves nuclear fusion in its core, it enters what is known as the main sequence. This is the longest and most stable stage of a star's life. Our Sun is currently a main sequence star, and it will remain so for billions of years. During this stage, a star fuses hydrogen into helium in its core, releasing a steady stream of energy. The color and brightness of a main sequence star depend on its mass. Section 7. Stellar evolution, the fate of stars. The fate of a star is determined by its mass. Stars like our Sun will eventually exhaust their hydrogen fuel and begin to evolve off the main sequence. As a star runs out of hydrogen, its core contracts and heats up. This causes the outer layers of the star to expand, and the star becomes a red giant. Section 8. Supernovae, the spectacular demise of massive stars. Massive stars, much larger than our Sun, have a more dramatic end to their lives. These stars end their lives in cataclysmic explosions called supernovae. During a supernova, the core of the star collapses, releasing an immense amount of energy. This explosion can outshine an entire galaxy for a brief period. Supernovae are essential for distributing heavy elements throughout the universe. Section 9. Conclusion. Unlocking the secrets of the universe. Studying stars allows us to peer back in time and understand the evolution of the universe. By analyzing the light from distant stars, we can determine their composition, temperature, and motion. Stars are not merely points of light in the night sky, they are dynamic, evolving objects that hold clues to the fundamental laws of physics and the origins of the universe. The study of stars continues to inspire awe and wonder, reminding us of the vastness and beauty of the cosmos.